So in Java, the trees are very similar to other languages. There's not anything unique about Java that's going on here. Though Java is kind of nice because the data structures and pointers and everything else like that is a little bit simpler to manage than in C++ and some of the other languages, though the concepts are absolutely the same regardless of the programming language you're dealing with. Um, Java has a built-in set list map hierarchy, as you hopefully know by now. The exercises we're going to do in this class are almost identical to that set of interfaces. The size is empty, contains to array. All those methods are really just clones of what was in that Java interface. I've taken out a few of them, and I've added in one specific one, height, to help us as we go through building and or testing our trees. So each of these methods inside of the tree is something that needs to be implemented at some point if you're going to pass every test case. But as I'll show you right now, you can run this right now and it actually is functional. It just doesn't pass any of the test cases. So you can see we have 1, 2, 3, 4, 5, 6, 7, 8 methods as part of our simple set. And we have 1, 2, 3, 4, 5, 6 tests out there. So some of these are like the height one specifically is tied to adding into the tree, and there's a few of these that are kind of tied in together that we test them together. So like size and is empty gets tested at the same time and whatnot. So you know, at some point you'll get points for implementing each one of these, and each additional one you get additional points on. The hardest ones for sure are add and remove. And they're even more challenging later on when we get to balance trees, but that's a topic for another time. But you get points for any one of these you get up and working as a network. You don't have to have everything working. So if you can get either add or remove going, that's plenty of points to get you by your understanding of trees, your bare minimum requirement with a few of these other ones right there. For those of you seeking an A, just put in the work, ask the questions, keep nailing on this until you get all of these working and you'll be good to go. So the testers, you're welcome to go read the test code. It's out there. Let me just show you real quick. It's quite simple. You have a interface right here, which is the simple set. And then there's two implementations of that. The first one we'll focus on is the simple tree set. Um, I want to point out that I'm using a set instead of a symbol table / map implementation for trees. Just simply because I just want to keep that one tiny little nuance of key and value separation, just take that away and keep it simple. Basically, the only difference between a tree set and a tree map is you have a second value, which is the value, and the key in this case and the value are the same thing in a set. So all the rest implementation is essentially the same. It's again keeping things a little bit easier. Um, as you do your work, you'll do your work for starting in the simple tree set, and then later on, next week, following week, whenever you get to it, you can take on the balance tree set, which, by the way, the balance tree will be the same implementations for several of these methods. So I have provided for you a starter of what your node is supposed to look like here as well. If you want to tweak your node based off of the algorithm you're pursuing or some other different way of implementing it, if you want to change where these methods reside, if you want to do the recursion slightly differently, everything can be changed except for these methods that adhere to the interface. Anything that's not in this interface, you can change. Any data structure, you can change. All it needs to do is implement this interface and the tester will work fine. So if you decide that you don't want to call this left and right, you want to call it something else, call it something else. Um, if you want to add something to the constructor, change the constructor around, perfectly fine. If you want to add methods inside of your node, no trouble. So as I said, as long as it doesn't have an at override on it, which I think the size is supposed to. Let me just add that right now and make sure that's working. Then you're welcome to go off and change that, and it should pass the test cases and go from there. Um, this will be more of a factor when you get to the balance tree. We'll talk about that more later on. There's a bunch of extra methods in the balance tree that I left around as stubs for you to use later on. Um, so the idea of the coding exercise is not for you to take these rough videos and reverse engineer them to come up with algorithms. There's algorithms in the book, there's algorithms online, there's code online. You're allowed to look at those things and write your own version of them. So I have tiny little tweaks of each of these functions. They're not meant to be confusing. They're meant to fit into the test case I'm trying to do, to simplify some things. And your your exercise is not reinventing the wheel on how a tree works. It's in taking the existing algorithm descriptions, the existing code, the existing videos, the existing whatever's out there, and build your implementation of that. To some degree, it's easy because you can use an existing algorithm. In some way, it's hard because you have to riff on that slightly to conform to a new interface. It's not a simple task. But as long as you're not just copying and pasting lines of code, you're fine. Just type them in yourself. Understand each line of code that you're writing. So I just want to give you this quick overview of what this structure looks like, maybe help you contextualize the rest of these videos of what you're going to be building, what you're going to be working on. Um, feel free to reach out for help at any time. Feel free to ask if you're not sure where to get started. And feel free to, as I said, check out the test code. By the way, this test code, there's two testers, balanced and simple, but they only really add one method where I'm testing the height of the tree. That's the only thing that's really different between the behavior-wise of these two different types of trees. All the rest of the tests are the same. The tests may or may not tell you a ton. I don't expect you to reverse engineer the tests to understand how trees work. They're really, at a very functional level. I will point out there's a extra little Boolean variable up here, debug, that you can set to true if you want to. And if you do, as it adds things in, I'm just going to scroll down here, you can see if debug, then it's going to print out some extra things of as things get added in. So you can see what was added into your values if you don't want to have to use the debugger a whole lot. If you just want to use print lines, this will help you see what your code is receiving as it gets filled up with the tree. All right, so I'm going to leave it there. Let you go back to the concepts of trees. We'll look at some code and some details in a little bit.